Alright guys, so today we start pretty much the last new thing that we're going to learn this year, which is the quadratic formula. Okay, some of you might have heard this before. This is something that you'll see a lot more of in Algebra 2. Okay, and so if you are going into geometry next year, you might not see this as much, but you'll see it once you get to Algebra 2. Okay, and so we've been solving quadratics now for the past couple of weeks, and you had a few problems like that on your SOL. But today we're going to kind of take that a step further and learn what to do if we can't factor it nicely. We have to use this kind of long, annoying formula that you see here in front of you, which is called the quadratic formula. Okay, and there is a very stupid song that goes along with this, and I'm not going to sing that out loud right now because that's kind of ridiculous since I'm on a recording. So if I was in class, I'd be singing the quadratic formula song to you right now, but that's not going to happen. All right, so quadratic formula. What we're going to do is we're going to kind of move right to an example here. Okay, I want you to kind of continue looking at the formula above you, okay, because you're going to need to use this for all of these examples below in your notes. But pretty much you're going to take the middle term, so it's negative b. B is your middle term, right? We've learned kind of this general form, y equals ax squared plus bx plus c. You guys have seen that before. That's your general form for a quadratic. Okay, and so we're just kind of following along with this formula now. Every time we're solving for x, if I can't factor it nicely, then we're going to have to use this formula and fill in a, b, and c where it should go. And so the only thing I want you guys to know about the quadratic formula right now is that in order to use the formula, you do need the equation to be equal to 0 or set equal to y. Okay, so if it's not equal to 0, then you're going to have to do one more step before you can use the quadratic formula. Okay, and so we're going to move on here to an example. All right, and I'm going to write just up here, I'm going to write the formula again because I don't see it up here. I know you guys see it on your papers, but I need to see it up here too. Okay, and so I'm going to write the formula up here. Okay, and so this is pretty much just what I'm going to follow along with here. So number 1, I have negative b, okay, and so 9, we have our a, which is out in front here, we have our b, and we have our c. You all know that if there's no number out in front of that x squared, then that's a 1, right? So our a is equal to 1, our b is equal to 9, and our c is equal to 14, okay, and so this is what we're going to follow along with now. So I have x equals, because again, when I'm using the quadratic formula, I'm solving the equation, so I want to find the roots. I want to figure out what my x-intercepts are, right? Roots, solutions, zeros, all those words that we've learned for x-intercepts. And so I'm going to use negative 9, okay, so it's negative b, so negative 9 plus or minus, okay, the square root of, and it's b squared minus 4ac. And so I'm going to do b squared, that's 9 squared, minus 4 times a, which in this case is 1, and times c, which in this case is 14. Okay, and that right there, all of that underneath of the square root, b squared minus 4ac, that's what we call the discriminant, and we're going to talk about that. In a little bit. And that is all over 2 times a, and so it's 2 times 1. Okay, and so now I'm just going to solve this. So I have negative 9 plus or minus the square root. Okay, and if you put this in your calculator, it's going to be 81 minus 56 all over 2. Okay, 2 times 1 is 2, right? And so negative 1 plus or minus the square root of 25. 81 minus 56 gives me 25 divided by 2. Okay, now what's nice about this is square root of 25, that's nice and easy, right? We don't have to really simplify that. That just we know is 5, right? So negative 9 plus or minus 5 divided by 2. Okay, and so now I need to actually get what x is equal to, and so I'm going to solve each one of these separately. So I have negative 9 plus 5 divided by 2. Okay, and so that's going to give me negative 4 divided by 2, and so my first root is going to be negative 2. Okay, then I need to take, again, it's plus or minus, and so I need to now take negative 9 minus 5 divided by 2. Okay, and so that's going to be negative 14 divided by 2, and so that's going to give me negative 7. And so you can see here negative 7 and negative 2, those are my two roots. And so again, when you can't factor something nicely, okay, the first thing that you should be thinking of is that you're going to have to use the quadratic formula. Okay, now you will see in this case y equals x squared plus 9x plus 14. You can factor that one. That one is factorable, but because we're learning how to use the quadratic formula today, we're going to solve each one of these using that formula. Okay, and so it may seem like we took the long way out here instead of the short way out, right? But we do need to kind of practice with the formula, and there will be many times where you have a polynomial that you can't factor nicely, and so you will have to use the formula. Okay, and so that's the first one. I'm going to go ahead and get rid of that. I'm going to get rid of these, everything that I just wrote here so that I have more room. Okay, and I'm going to move on to number 2 now. And so again, it is set equal to y, so I know that I can use the quadratic formula. So x equals negative b, right? And so in this case, my a is equal to negative 1 here, my b is equal to 2, and my c is equal to negative 1. Okay, and so my x is equal to negative b, that's my formula, right? So negative 2 plus or minus the square root of the discriminant, and so that's b squared minus 4ac. So b squared, 2 squared, minus 4 times negative 1 times negative 1. Okay, and all over 2 times negative 1. Okay, and so I have negative 2 plus or minus the square root of 4, 2 squared is 4, minus 4 times negative 1 times negative 1, and so that's going to be just 4 all over negative 2. Okay, and so we're going to talk about, you saw there that we actually, underneath the square root now, we actually get 0, and we're going to talk about later what that means when we get 0 as our discriminant. Okay, and so our answer here, we have negative 2 plus or minus 0 all over 2. And so again, I want to find my two answers, but what we notice here is that whether we do negative 2 plus 0 or negative 2 minus 0, we're going to get the same thing. And so we just have negative 2 divided by 2, and so that's going to give me negative 1. And so in this case, my only root, my only x-intercept is negative 1. Okay, and again, we're going to talk about what that means and why we know that there's only one answer when we get 0 underneath of the square root. We're going to talk about that later. That has to do with the whole discriminant thing again, okay? All right, and so now we're going to move on to number 3. And I'm going to just move this up a little bit here so I have more room. And again, number 3, you can see, is already a little bit different. This is set equal to negative 5. And so I need to move that negative 5 over to the other side. I need to set it equal to 0 before I can use the quadratic formula, before I can factor, right? We've learned with quadratics, I can't factor anything until it's set equal to 0. And so in this case, I also can't use the quadratic formula unless it's set equal to 0. And so I'm going to add 5 to both sides. And so it's plus 5 is equal to 0. Okay, and now, once again, my a is negative 1, my b this time is negative 2, and my c is 5. Okay, and so now I can use the quadratic formula. So x equals negative b. Now my b is already a negative number, so if I take the negative of a negative number, that's just going to give me a positive. We know that, right? So it's positive 2 plus or minus the square root of b squared, so negative 2 squared. Notice how I put that inside of parentheses. Okay, if you're squaring a negative number, you know that a negative times a negative is going to give you a positive. So b squared minus 4 times a times c, all over 2 times negative 1, 2a. Okay, and now I'm just going to solve this again. And so on the inside here, negative 2 squared, I know that's going to be 4, minus 4 times negative 1 times times 5, and so that's going to give me negative 20. And so really I'm going to be adding what's underneath the square root there. Right, and so I have 2 plus or minus the square root of 24 divided by negative 2. Now this one's not as nice as what we've had, right? This is the square root of 24. I'm going to have to simplify this. Okay, and we are going to review radicals again next class for those of you who may have struggled with that on your SOL test. Okay, square root of 24. I need to break this up. I need to break this up into something, right? I know that the square root of 24, it's not quite simplified, but it's also not a perfect square. And so I need to split it up into two. I need to find the factors of 24. One of them's got to be a perfect square, right? And it has to be as simplest as it can, as simple as it can. And so I'm going to split this up into 4 times 6. Okay, and we know, and I'll still put it over negative 2. Okay, and so this now is just going to be, let me erase that real quick. And so this now is going to be, we know that the square root of 4, that's just 2, and so I'm going to take that 2 out of the square root, but I need to keep the 6 inside. I didn't touch the 6, and so the 6 needs to stay right where it is. Okay, and that's all over negative 2. Now you can see here, we can actually simplify this a little bit further. 2 divided by negative 2, right? 2 divided by negative 2, that's going to give me negative 1. Okay? Now you can't simplify it unless both of the terms in the numerator, okay, can divide evenly with that denominator. Okay, so you need to make sure that both of those terms can be simplified with what's in the denominator. And so right now you see that it's negative 2. I can divide negative 2 evenly into both of those 2's that you see in the denominator. And so this is just going to give me negative 1 plus or minus negative root 6, right? The 2, they all cancel out and they all become 1's, right? And so now I took care of the negative. I don't have to put the negative on top anymore. Okay, this would just turn into 1 on the bottom, right? This would just be over 1 on the bottom now, right? Because I took care of that. 2 divided by negative 2, that gave me negative 1. And when I did 2 divided by negative 2 again, that also gives me negative 1. I put both negatives on top, and so now I'm done. I can just say negative 1 plus or minus negative root 6. And again, that's going to be my answer there, okay? I'm not really going to split that up. Those are 2 different roots. Those are 2 different x-intercepts, and so I don't have to really touch that anymore. Now I'm done, okay? And so your answer can look like that. If it can't end up being a nice, even whole number, then you can leave your answer just like that with a square root in it, okay? And so that's going to be my answer there. If you have any questions on that one, I know that's a little bit of a tougher one, so if you have any questions, make sure you ask somebody in the room, okay? Alright, and so we're going to do the last one now. Again, my a, this is set equal to y, and so I'm ready to use the quadratic formula. A is equal to 2, b is equal to 6, and c is equal to negative 9. Again, make sure you pay attention to your signs there. So I'm going to use the quadratic formula. X equals negative b, which is negative 6, plus or minus the square root of b squared minus 4 times a times c divided by 2 times 2. Okay, 2a, right? And so equals negative 6 plus or minus. I'm going to take care of the discriminant, what's underneath of the square root. Okay, and so that's 36 minus 4 times 2 times negative 9. That's going to give me negative 72. And so this is, again, this is going to turn into a positive. Okay? And we will talk about this. And this is actually going to be over 4 here because it's 2 times 2, right? And so we will actually talk about this. You can never have a negative under the square root, at least for right now. Okay, we don't want to have a negative under the square root. That would actually give me imaginary numbers, and right now I only want to deal with real numbers, okay? And so if you have a negative under the square root, okay, for right now you don't have to worry about anything else at that point. At that point you can just write no solutions because we want to make sure we have a positive number under there, okay? And so this is going to be negative 6 plus or minus the square root. If you add 36 to 72, you actually get 108, and so that's what that's going to turn into there, divided by 4. Okay? And so then we have negative 6 plus or minus. Once again, I'm going to split up 108 into, we need to find the factors of 108. Remember, one of them needs to be a perfect square. And so just for time purposes here, 36 times 3, that's going to be my factors of 108. And you can, let's see, divide by 4. And so that's now just going to be the square root of 36. We know what that is. That's just 6, right? And so I'm going to bring that out in front of the square root. So it's 6. I'm going to keep the 3 right where it is because I didn't touch that, right? That stays inside of the square root. And that's divided by 4. Now, once again, I'm going to come up here. Sorry, not being confusing here. I'm almost done, okay? But I can actually simplify 6 over 4. All right, and for those of you who already realized that, that's awesome, right? But I can take this one step further now. So x equals negative 6 over 4. Okay, I'm going to write this up here, negative 6 over 4. We know if we divide both of those by 2, simplifying fractions, right, I'm going to get negative 3 over 2. And so that's what both of those are going to turn into. I have negative 3 plus or minus, that's also a 6. And so 6 over 4, that's also going to be 3 over 2. And so it's 3 root 3 all over 2. And so you can see there that is going to be my answer. So all I did there was I just simplified the 6 over 4. There's two 6 over 4s, and so I simplified both of those to 3 over 2. Okay, with the first one being negative because you do have a negative out in front. Okay, and so that takes care of my last one. Again, I know those last two were a little bit tough. All right, when we take our quiz on this in a couple of classes, you will be given the quadratic formula. You do not have to memorize that, so don't worry about that, okay? But I know those last two were a little bit tougher. Again, you're going to see a lot more of this in Algebra 2. We're just kind of learning the basics of the quadratic formula right now. So if you're a little bit confused by those last two, please don't hesitate to ask, okay? All right, and now flip over. And we're kind of on to our last part of the notes here. And we talked about this, the discriminant. Okay, so the discriminant, when you're looking at a polynomial or you're looking at the quadratic formula, okay, that's going to be what is underneath of the square root. And so you can see right here, these are our three cases. And so you can see b squared minus 4ac. That's what's underneath of that square root in the quadratic formula. Okay, and so that is going to tell us how many solutions there are in our answer. And so the very first case, okay, and I'm just going to write first here, the first case is when the discriminant gives us a greater than, right? That's going to be a positive answer. That's when the discriminant underneath, that's when underneath of the square root, it's going to give us a positive, it's going to give us a positive number, okay? And so that means that there's going to be two real solutions, and that means that there's going to be two x-intercepts. And you can see that by the graph right here. That graph crosses the x-axis twice, right? And so that means that there's going to be two x-intercepts, two real solutions, okay? Now, the other case, and this is case number 2, the second case, we actually had this case in one of those examples. We ended up getting 0 underneath of the square root. Okay, when we have 0 under the square root, that means there's going to be one solution. And if you look back to number 2 on your examples on your notes, we got 0 under the square root, and you notice that we actually got 1 as our answer there, right? And so and I think I'm realizing I may have said that the answer was -1. Make sure that that is a 1 as your answer in number 2 on your notes. I may have messed up on that earlier, so I apologize. Okay, so we have one real solution, and again, one x-intercept. It crosses the x-axis once, and you can see that on your graph. Okay, and finally we have our third case. Okay, we have our third case, which we didn't have an example like this, but you will actually have an example of this in your practice. And so make sure you are understanding what happens when the discriminant, when underneath of the square root, results in a negative number. Okay, that means that there's going to be imaginary solutions, right? And so in this case, okay, that means there's going to be two imaginary solutions. Okay, and that means there's going to be 0 x-intercepts. You can see here on this whole x-axis on the graph, it never actually crosses, right? So that means there's no x-intercepts. But there are still going to be solutions, they're just imaginary. Okay, and so just make sure on the practice that you're understanding what that means. When you do get a negative number under the square root, okay, that means that there are still solutions, but it means that there's imaginary solutions, okay? And so another one for you to write here, and I'm going to write this here, it means that there's no real solutions. And so for right now, I'm totally okay for, you know, on your quiz, if you end up getting a negative number underneath, if you want to write no real solutions, that's fine. Okay, you don't have to write two imaginary solutions. Okay, that's something that you'll see a little bit more of once you get to Algebra 2. Okay, and so we just have a couple of examples here. All right, again, rather than going through my whole formula, all I have to do now is b squared minus 4ac, because it says determine the number of solutions. We know that the number of solutions, all we care about there is the discriminant. And so I'm going to do, let's see here. I know that my a in this case is 2. I know that my b is 6, and I know that my c is 5. All I need to do is b squared minus 4ac. So 6 squared minus 4 times 2 times 5. Okay, and so if I do this now, 6 squared is 36. I'm going to subtract, what is that, 40? And so that's going to give me -4. So that would be a negative under the square root. Okay, and so we know that that means there are no real solutions. Again, if you get a negative under the square root, okay, that means there is no real solutions there. All right? We're going to move on to the next one. This one's a little bit different. We haven't seen this. This is y equals x squared minus 7. I'm going to rewrite this, and you're going to see how I rewrite this. X squared plus 0x minus 7. You still need to include that middle term, that b term. Okay, even if it's not there, that just means that it's 0. Okay, so my a is 1, right? Because if there's no number in front of the x squared, that means there's is an imaginary 1, right? Plus, oh, not plus, sorry. My b is going to be 0, right? That's not really given for me there, and so if it's not there at all, it means that it's 0, okay? It still needs to be included. All right, and then my c is going to be -7. And so once again, I'm going to do b squared, which in this case is just going to be 0, right? 0 squared is just 0, minus 4a c. So this is just going to be 0 minus -28. Okay, we know that when we subtract a negative, that's going to turn both of these into a positive. And so I have positive 28. That means there's going to be 2 solutions. Again, if you get a positive number as your discriminant, right, this is positive, okay, before we got negative, right, -4. There's a negative under the square root, there are no real solutions. If there's a positive, that means we're going to have 2 solutions, okay? And so this was our answer for number 5. This is now our answer for number 6. Okay, and so make sure you have those down. I'm going to go ahead and get rid of those so that I can have a little bit more room to do number 7. Okay? Alright, and so number 7 now, my a is going to be 4. My b, you can see, is -12. Pay attention to the signs. And my c is going to be 9. And so I have negative b, oh, no, sorry, this is not the formula, just b squared minus 4ac. That's all I care about, right? And so I'm going to take b squared, so that's -12 squared. Notice how I always put it in parentheses. If it's a negative number, get in the habit always, always, always of writing that inside of parentheses. Because you know if you square a negative number, it's going to be, and I took a break there because I know everybody should say positive, right? So -12 squared minus 4 times a, which is 4, times c, which is 9. And so this right here, -12 squared, that's going to give me a positive 144. And minus 4 times 4 times 9. If you do that in your calculators, okay, you will end up with 144. And so if I subtract both of them, that's going to give me 0. And if you remember from our notes, when we have 0 under the square root, okay, that means we will have one real solution. One real solution. And so that's our answer there. Okay? So when you get 0, that means that it's only going to cross the x-axis the one time. Okay? Alright, and the last 3 are pretty easy. You may have already worked ahead, and that's great. You can see here, number 8, it crosses the x-axis twice, and so we know this is going to have 2 real solutions. Okay. We know in number 9, you can see that it never crosses the x-axis. We know that means it's going to be imaginary, but again, as far as the solutions, I'm okay with you writing no real solutions. You don't need to worry about writing imaginary. Okay, and so no real solutions is going to be our answer there. And then finally, I have one solution in the last one. Again, it's crossing the x-axis just the one time, and so there's going to be just the one real solution in number 10. Okay, that again, that means that my discriminant is equal to 0, and so I'm going to write that up here. Minus 4ac is equal to 0. Over here, my discriminant is less than 0, right? It's a negative number. That means it's no solutions, no real solutions. It means it's going to be imaginary. And then finally, in number 8, I have that it's going to be greater than 0. It's going to give me a positive number, and that's how I end up with 2 real solutions there. Okay? So that takes care of our notes for quadratic formula. All right, I want you to work with your partner next to you, or if you'd like to work by yourself, that's fine. But you may go ahead and start working on the practice now. Okay, and make sure that you are working. It's only 7 questions, as you can see, and this will be homework if you do not finish it today. All right, thanks for listening, guys.